Station, this is Houston. Are you ready for the event?
This is Houston. Are you ready for the event?
And Houston Station, ready for the event.
United States Coast Guard Academy. This is Mission Control Houston. Please call station for a voice check.
This is the United States Coast Guard Academy. How do you hear me? How do you hear me?
And Coast Guard Academy, this is the International Space Station. Ron, we've got you loud and clear. How cool is that?
Dan, I'd like to introduce you to our Superintendent, Admiral Stokes, who will say a few words to you.
Hello, Dan. It's great to see you, Captain Burbank. It's just wonderful to see a Coast Guard presence, not just in the waterways, on the seas, international, but now in space. And thank you so much for influencing a generation of young students, not those in this room, but the young elementary school students around the country and the world that you're influencing and encouraging to be interested in science, engineering, technology, and math. Thank you.
Admiral, it's great to talk with you, and welcome aboard the International Space Station. And it's a real pleasure. I can't tell you how delighted I am that we got a chance to come on board in London there and spend some time with cadets. It's been a couple of years since I logged a few years in the faculty there, and I really enjoyed the time. I absolutely enjoyed my time in the service, and the whole time I've been up here, I've been able to feel very, very connected. I constantly am reminded of the Coast Guard by the various places that we fly over the Earth, and by the opportunity to talk to my friends over the phones. We've got essentially an internet protocol way that we can call people in our spare time, limited though it may sometimes be.
Well, Dan, you're
I thought what I do is just we have a it takes some getting used to, and I still can't say that I've gotten there. We've got a couple second lag in the communications, but it's probably an egregious violation of some protocol to step on an admiral's communications like that. You'll have to excuse me.
Dan, thank you for influencing
but anyways,
our cadets. We look forward to having you have some questions from them. I'm going to turn this over to them, who I'm sure won't step on you like I am.
All right, Dan, go ahead and share with us some of your experiences on Space Station.
Well, I've been here since the 16th of November. We had a little bit of a delay in our launch, and I don't know if folks were able to follow. We had kind of a snowy start from Baikonur in Kazakhstan. It was sort of a classic Coast Guard weather kind of night that we launched on. But the Soyuz rocket did a wonderful job, had a great ride uphill, had a couple of days in the relatively tight quarters of the Soyuz, and then we arrived here on board Space Station on the 16th of November. We had a little bit of a delay getting here because of an issue with a cargo ship a couple of months prior to that. So we've been kind of operating on Space Station at a reduced manning level for at least a couple of months during the late fall. And the time that we've had up here has been incredibly busy. All of us are a little bit of we have to be a jack of all trades. Every day you'll run into various different little hiccups or wrinkles that you have to deal with. The science is going great. The hardware, it's very, very challenging sometimes to keep all the hardware working and working well up here. And we always get a chance to kind of practice our jury rig and repair techniques sometimes. In fact, I don't know if I'd call it Marlin Spike seamanship. I got a chance to use a sailmaker's palm and some big sailmaker's hooks and sew up a light shield for microgravity science glove box we had. Got to tie a couple bowlines, lashing up the exercise equipment we have, and It's amazing where some of the skills that you've picked up over the years can be applied. But the time up here is absolutely delightful. Every day you wake up and you can't believe that you're actually living on board the International Space Station, flying in space, floating over to these windows, and looking at this breathtaking planet from 240 miles above.
Thank you, Dan. We have our first question from one of our cadets.
Good evening, Captain. This is First Class Cadet Tyler DeWecker. My question is this regarding the asteroid exploration. With the increased interest in asteroid exploration as well as defense, do you foresee an increase in the amount of astronauts that are accepted to NASA? Additionally, with the increased productivity of private space travel, do you foresee an increase in NASA astronauts going to be the pilots for private space travel? Or do you believe that they'll be privately trained, Captain?
Tyler, it's great to talk to you again, and thanks again for doing such a great job in Houston when you came down and spent time with us at the Johnson Space Center. A lot of questions there. I guess in general, I would say that the future for me looks very bright for space exploration. I know a lot of folks are a little bit concerned with the retiring of the shuttle. All of us who had a chance to fly on it, it's a bit of a bittersweet moment to see that great vehicle be retired and placed in museums. By the same token, though, the shuttle did exactly what it was designed for and had a wonderful many decades of launching satellites like the Hubble Space Telescope and Chandra X-ray Observatory, and most importantly, I think, in my opinion, building a nearly million-pound space station that we're living and working on. So right now, the work we're doing on Space Station is trying to figure out how to keep, for the American research, primarily centered on how to keep humans safe and healthy in space long enough so that we can leave low Earth orbit, go back to the moon to stay, on Mars, visit asteroids, and so forth. I think that is humanity's destiny. We're going to do those things. In the meantime, the time is ripe, I think, for commercial companies to step up and actually be able to do the things that up until now only whole countries could do, and that is to cover the piece from the surface of planet Earth to low Earth orbit. So I think it is a good thing, a healthy thing for us to have commercial vehicles initially doing this, supplying cargo to space station, but then down the road supplying a human capability to get to and from space station and to other destinations. At the same time that's going on, NASA's building or designing new vehicles, rockets that'll have a very, very big heavy lift capability and a capsule that allow us to leave low Earth orbit. All these things have to be done. We have to do this at the same time we're doing the research on station to make sure that we understand how to keep people safe. If we're going to leave low Earth orbit, that's a very, very big step. And the research we're doing right here, I think, is going to help us to be able to answer those questions. But the bottom line, the near term for you guys, when you graduate, when other service members graduate, when folks in engineering and science programs all around the country graduate and are looking at jobs, whether it is joining the space program, helping us build vehicles, or whether it's joining the astronaut corps to fly, I think the future is bright. It's better than it was for me when I was in that same position.
Thank you, Captain.
Good evening, Captain Burbank. Second class Rachel Cottrell. My question for you is, with using so little energy throughout the day, do you find it more difficult to sleep at night, or have you noticed any change in your sleeping patterns? And additionally, how do you continue to keep your muscles strong working in an anti-gravity conditions?
Okay. Well, the first thing is we get a lot of our energy, electrical power, from the sun. So we have about an acre worth of solar rays that gather and convert photons basically to electrons. That does a lot of the electrical power generation that we need on board Space Station. On the Russian segment, we have the capability of taking water, making oxygen. We use the sun's power to actually do the electrolysis to make that work. We're working really hard on board Space Station right now to close the water loop, if you will, to basically reduce our dependence on resupply ships to supply us with water that we use to drink, to rehydrate food, and we use to break down to make oxygen. That's kind of the engineering piece of all this. From the standpoint of sleep cycles and so forth, we have a lot of challenges in that. All of us depend on the day-night cycle to kind of regulate serotonin, melatonin levels to help us sleep or be awake as appropriate. On board Space Station, we kind of artificially regulate that by the lighting and so forth. So we basically have 15 to 16 sunrises and sunsets every day. So every 90 minutes, we're going from day to night. Or like a couple of weeks ago, we may be in daylight because of the orientation of the space station's orbit relative to the sun angle. We may be in daylight continuously. So if the windows were open all the time, it would be, I think, very, very hard to sleep. So we kind of regulate that artificially. What else about that? We would like, and I think it's a good thing down the road, to consider having more natural light than the fluorescent lights that we have right now. That'll basically give you the right mix of blue light to actually be able to regulate it and make it more like natural conditions on planet Earth. A pretty long-winded discussion, but that kind of covers a little bit of the engineering side, a little bit of the sleep side. The exercise is a key piece. That's one of the biggest threats to going to Mars, for example. So a couple years ago, maybe 10 years ago or so, when we were flying on the Shuttle Mir program and programs before that, crews that would be on orbit for a long period of time would lose a pretty significant amount of bone material while they're on orbit. Basically, you adapt to the conditions you're in. The use it or lose it philosophy is in strong effect. So if your bones aren't being stressed, then you don't need those minerals. Your body uses those resources and puts them elsewhere. We got a really good exercise machine right now, Advanced Resistive Exercise Device, ARED we call it. If we can ever think of the acronym, that's usually by exception. That device allows us to get up to 600 pounds worth of load. So we can do, not that I can squat 600 pounds, but we can get very, very high loads relative to what you might get in a gym on the ground. That we think is key to keeping your bones strong. Loading the big joints is really, really important. That's part of it. Cardiovascular conditioning is another major part of it as well. We have to exercise about 2.5 hours a day. When we get behind because we're real busy and we let that slide, that's kind of a big hit to us. We need to make up that time because if we were going to live in space forever, it would be no big deal. We want to come back to Earth, or we'd like to maybe at some point land on Mars, and we want to be able to function in either of those environments.
Thank you, Captain.
Good evening, Captain. This is First Class Joe Dillier. I had the privilege to take SED from you back in 2008 when I was a fourth class, and my question to you is kind of, I've got two questions. One's real practical. Are all the bolts on the space station, are they English units or metric units, or are they some sort of mix? And then also, you mentioned it was like a 1 million-pound space station. What kind of structural challenges were there in designing it and keeping it together? Because, I mean, I know it's a zero-gravity environment, but if it's zero gravity, then, I mean, this question has been bothering me for a while, sir.
No, the great questions, all those. Let me see. The second part of that was, okay, actually the first part was easy. We have a mixture of units, so we all have to either do the conversions in our head or get relatively comfortable with metric and English units, and that's just the way the station is. And it's kind of a reflection of the heritage of the space station throughout its design. So dating back to the 80s, this was basically an effort, Space Station Freedom back in those days, and it was a NASA effort, a European Space Agency effort, Canada, and the Japanese JAXA, the Japanese Aerospace Exploration Agency. So, and for a long, long time, this has been under design, and it had gradually evolved over years and years. Fairly late in the game, the Russians joined this program, and they had already a design philosophy for a lot of their modules. They have their heritage back with the Mir modules, for example, and those were integrated to the rest of the space station. It's really actually a very intriguing design from an issue from an engineering standpoint. You're basically having to figure out a way to build the space station and build it on the fly, like you're flying an airplane, adding a wing, adding landing gear, what have you. So the space station had to be able to take care of itself, motion control, electrical power, thermal control, environmental control, command and data handling. All these systems had to all work gradually as you evolved it from a very, very small handful of modules early on to what it is currently. And that was an incredible challenge for the people that were designing it. Some of the modules, some of the mechanisms were basically going to attach to modules and mechanisms that they would never see. We would never attach them ahead of time. We would basically do all our homework ahead of time, make sure that all the drawings match, make sure all the communication protocols for the command and data handling systems would hopefully all lash up, launch it, attach the stuff, and then if the issues that came up as things were assembled, deal with those. And those were successfully dealt with throughout the entire assembly. It is a real testament to the people that put together that actually conceived of and adapted the design of the space station over the years. We've never done this before. In the United States, for example, we have always designed spaceships, built them essentially in a hangar, attached test gear to them, and been able to ring them out, basically evaluate them through all different kinds of conditions, and almost always make changes to that design and essentially have an entire spacecraft ready to mount on a rocket and launch it. Here we are building you could never do that with space station. It's so large. So you essentially have to figure out how to do all those things and do it ahead of time, and then anticipate and be ready to adapt to all the issues that might come up over the years. That's the kind of thing you really have to be able to do if you're going to go to Mars, because we're not going to be able to launch hardware, anticipate all the things that are going to break, launch all the spare parts that you need for all of that, and expect everything to work, and be reliable for 10 or 15 years. It just doesn't happen. So figuring out how to fix and maintain things as they go, that's key. For space station, the loading on the hardware that's up here, it's not the constant steady state gravitational loads that structures have on planet Earth, but it's impulse loads, it's high cycle fatigue loads, it's crews moving around in the space station pushing off of handrails that are offset by 150 or 200 feet from the center of mass of space station, and potentially exciting a mode on that structure. And we want space station to last out to 2028, maybe longer. And to do that, we need to make sure that we understand how all the mechanisms are, how they're going to deal with high cycle fatigue issues, make sure we don't have corrosion issues as well. So it's a big challenge, and it's the kind of thing we need to be able to monitor it as it goes and adapt and fix it as it goes.
Thanks a lot, Captain.
Good evening, Captain Burbank. This is First Class Aaron Nolan, and I was wondering if you could tell us a little bit about one of the most interesting research projects that you're currently working on the International Space Station.
Okay, and one of the ones that I'm doing right now, that all of us that are crew members right now are either subjects, and I think probably in all cases subjects, but certainly operators as well for, is a study called Integrated Cardiovascular. And this is a study that basically takes a qualitative and a quantitative look at how the heart changes, how the heart muscle changes over the conditions of spaceflight for the duration of the mission. We do that basically by using ultrasound to image the heart. All of us basically had to become pretty decent ultrasound technicians before we launched, so that we can, under some supervision and guidance by the ground, be able to get good imagery that can help scientists on the ground understand how the heart muscle changes. And that, coupled with studying the vascular systems, we do the same kinds of studies, understanding how the blood vessels all change. They are actually a key part of our cardiovascular system, and they are holistically viewed. They're actually a huge contribution to doing the effort of pumping blood around your body. And when you're on planet Earth, through the gravitational force that you're constantly undergoing, those muscles, the muscles that are in the walls of the arteries in your blood vessels, basically help maintain the blood pressure, help push the blood, help fight the force of gravity. And once you get up here, that no longer is a factor. Those muscles lose their strength. You lose some of that functionality when you're actually subject to a condition called orthostatic intolerance when you get back to the ground. And you can, in an immediate near term, it can cause fainting and things like that, but it has grave implications for long-term health if you're sending people, long duration out to Mars, for example. So we're doing those kind of studies. At the same time, we're doing exercise studies and trying to understand just how the body adapts and changes in space-like conditions.
Thank you, Captain.
Evening, Captain Burbank. This is Cadet First Class Ryan Webb. I also remember the glory days of SED that we had a few years back. I was reading recently of your involvement with the...
Hi, Ryan.
Good to hear from you, Captain. I was reading about your involvement with the EPIC mission and the implementation of such drastic new computing software that you've been doing. I was wondering if you wouldn't mind speaking more to the challenges that you've faced while upgrading the space station, and also ways that you've overcome those challenges.
Okay, I'll just give you, I've got to keep the answer short so I get to everybody, Ryan. But I think one of the biggest challenges here operating on space station is managing tools and equipment in a weightless environment. And everybody works in their garage or works in the lab on the first deck of Mac Hall, for example. gravity is a great organizer. Basically, if you drop a tool, if you lose a tool, it's essentially limited by the XY plane of the floor. So maybe it's a socket and it rolls under a workbench, but at least it's at z equals 0. In space, that's not the case at all. So here, if you're putting together some delicate equipment, for example, and you've got a Ziploc bag full of fasteners and full of washers, and you've got wrenches, and you've got a flashlight on your head, and you've got all these other equipment and accoutrements that go with that. Keeping track of all those things, if anything were to slip and get away from you, that is a big deal, because that potentially is going to float into some of the high voltage wiring we have in the U.S. segment, for example, within the racks. So all things that are metal, all little fasteners and so forth are a big issue, keeping track of it. So for us, getting good at that, figuring out how to maintain things, how to place a tool, for example, that may be a delicate piece of equipment, and just let it float in front of you, keeping one eye or being aware of where its presence is at the same time that you're, stretching out a piece of duct tape and very carefully, putting washers and fasteners and organizing them so that you can do a task efficiently without losing anything. That's key, and it's something we don't necessarily deal with on a regular basis, but it's one of the survival skills of being able to work well on board space station.
Thank you, Captain.
Dan, we have one final question for you. Go ahead.
Captain Burbank, third class Carter Schlenk. I heard that you were a helo pilot while you were in the Coast Guard, and I've also read that you have some time in a T-38. I was wondering if you could tell us a little bit about your transition, and was that on your own time, or was that on NASA's time that you did that?
Now, actually, it was on NASA's time, so all government time. When you come to NASA, regardless of whether you're a military test pilot before you came here, NASA's going to train you to fly T-38s. And we're looking down the road at perhaps getting other aircraft added to the suite or the fleet of airplanes that we have. I think it's a very valuable thing for people that come with an aviation background or very operational background. You've got a certain skill set that is applicable to flight, to space flight, even though you may not be flying vehicles or operating vehicles that bear strong resemblance to whatever it was you did before. But the way you think about a task, whether it's hovering a helicopter over a boat on a dark, stormy night, that is similar enough to how you would fly the space station robot arm, for example, grappling a SpaceX Dragon capsule. That those skills map very, very nicely, from one arena to the next. For people that come with engineering backgrounds and science backgrounds and that are physicians and so forth, all those backgrounds are critical to the kinds of things that we do on board space station, but they may not necessarily give you the same kind of monkey skills, the same kind of what we would say crew resource management or cockpit resource management kinds of skills that are real important in flying in space. So flying in T-38s helps us a lot for critical decision making, helps us a lot for just hand-eye coordination, and it helps us, I think, also for just having a very good general awareness for the criticality of flying operational hardware in potentially dangerous kinds of situations. Now, with all that said, the Coast Guard flying is not all that different from, in my experience, from the T-38 flying that we do. And I think one of the most important things about the experience I had in the Coast Guard relative to flying in space that I think maps very, very well, and this doesn't necessarily apply to helicopters, but any operational Coast Guard unit or any kind of setting like that, we generally operate with small teams that have a mixture of people, all with different skills, that all have to come together to do potentially a very critical mission. That is exactly the way you fly spaceships. That's exactly the way you fly robotic arms in space. That's exactly how you do spacewalks when you're operating in an EMU outside the space station. So all of those kinds of things, the way you think, the way you work with people in those kinds of situations, is great training ground for this kind of business. And I think it benefits the Coast Guard to have people doing this, and I think it also benefits NASA to have people with our kinds of background doing this business.
Thank you, Captain.
Dan, on behalf of the Coast Guard Academy, thank you and your entire crew.
Just like Old Home Week. Thanks. It was a real pleasure. I'm so delighted that we're able to do this. And fair winds, following seas to you all. For all the firsties, I'm not sure, I've lost track, but if Billet Night's coming up, I hope all that goes well. If you're thinking about just going aviation because you're in the Aero Club and all the rest of it, it's not necessarily a bad idea. This is from an old guy saying this. I don't think it's necessarily a bad idea to consider going to a ship first. It's also a really good experience. But anyways, best wishes to you all. And we got a great service, and I'm proud of you all, and I can't wait to see and hear about your futures as you leave the academy and go on to great things.
Thank you, Dan.
Station, this is Houston ACR. Thank you. That concludes the event.
United States Coast Guard Academy. Station, we are now resuming operational audio communications.